Every community needs water. People in this town know that the tank they see near their post office holds part of their important water supply. They need water at home, mainly for cooking and for their personal comfort and health. Factories and businesses in the community also need water. Water for agricultural purposes is furnished by many communities. Water in swimming pools contributes much to the recreation of the community. And water to fight fire is essential to a community's safety. Every community must be sure of having enough water for all its particular needs. Where can we find water? Water is in the air and in the clouds that float in the air. Water evaporates into the air from all the oceans, lakes, and rivers of the earth, and from the surface of the earth. Eventually, this invisible water vapor changes back into tiny droplets of liquid water which form clouds. When the droplets of water in the clouds increase in size, becoming large, heavy drops, they fall to the earth again in the form of rain, or in another form such as snow, sleet, or hail. Some of this water runs off into streams and lakes to become our surface water supply. Much of the water that falls on the ground seeps into the earth, and so water that has evaporated returns once more to earth, completing its cycle. Each community gets its water from its largest convenient source of supply. Some communities get their water from lakes, some from rivers, and others from mountain streams that may be near or hundreds of miles away. Streams and rivers are often dammed to form reservoirs. Here, water is stored for later use. While surface water often has to be carried many miles, this is not usually the case in communities that use water that is in the ground beneath them. These communities drill wells into the ground. Groundwater seeps into them and accumulates. It can be pumped to the surface, used, or stored if desired. Groundwater is usually cleaner than surface water, which is exposed to impurities of many kinds. Most water, before it can be used, must be purified. The steps in this treatment depend on the condition of the water supply in each community. In many communities, for example, once surface water has been drawn from its source and held in storage, a step in its treatment is making the water clear. This can be done by settling and filtration. In the reservoir, both processes start. While heavy solids, such as mud and silt, settle to the bottom, floating solids are caught on screens that keep them out of the water system. When the water reaches the treatment plant, it usually is kept in large settling basins for a time to let more of the tiny solid particles settle out. In the treatment plant, certain chemicals, such as alum, are often added to speed up the settling process. Such chemicals, called coagulants, make the tiny suspended particles in the water cluster together and sink to the bottom. The nearly clear water then runs into filter basins, where the other sediments that might still be in the water are filtered out. This cutaway model of a filter basin shows how water is filtered by seeping down through layers of fine sand and gravel to runout pipes at the bottom. When the engineer opens a valve, the water in each basin slowly begins to seep down through the layers of the filter. Every few days, engineers must clean the layers of the filters by a process called backwash. In backwashing the basin, clean, filtered water is forced in at the bottom. It rushes up through the layers of the filter, washing away the mud and foreign particles that have accumulated there. After the waste from the filters is washed into a trough, it is pumped to a sludge pit. Here, much of the wastewater evaporates, leaving the sludge, which is later taken away. Sludge removal is generally the last step in making surface water clear. But where the community source of water is in the ground, the earth as shown here in cross-section, acts as a natural filter. As groundwater seeps through soil, sand, gravel, and porous rock, most suspended matter and other solid impurities are removed. But the need to make water clear is only one reason for treatment. There are many other special problems. When water seeps through the ground, it often dissolves and picks up certain minerals. When soap is added to such water, these minerals keep the soap from working effectively. This kind of water is called hard water. To correct this special problem, water must be treated by a process called softening. Water is frequently softened chemically by adding lime and soda ash. In settling basins, these chemicals combine with the dissolved minerals in the water so that they will settle out. A coagulant is often added to the water to speed up the settling action in the basin. After the water is softened, it is easy to get a lather from soap. Groundwater often picks up other minerals and gases that give it a bad taste or odor. It is desirable to remove them. By spraying water into the air, or by passing air through water, these substances can be removed. The oxygen in air combines with them, forming new substances which can later be filtered out. This process of bringing water in contact with air is called aeration. Surface water, too, may have a bad taste caused by microscopic plants called algae. Sometimes water is treated with copper sulfate to kill algae. There are a number of other, less common special problems that different communities face depending on their own particular water source. But one step in water treatment common to most communities is the killing of bacteria, most commonly done by chlorination. At the treatment plant, a poisonous gas called chlorine is added to the water. But the amount of chlorine added is so small that it is harmful only to the bacteria in the water. To be sure that enough chlorine has been added to kill the bacteria, samples of the water are tested at regular intervals. In addition to tests for chlorine content, tests are also run to make sure that any remaining bacteria are completely harmless. Still more tests may be required, depending on the nature of the water supply in different communities. In a growing number of communities, chemicals which contain the element fluorine are added to the water. Fluorine in drinking water helps prevent tooth decay. When the water has passed all these careful tests, it is ready for storage and distribution in the community. When water is ready for distribution, it may be pumped, or it may flow by gravity from high tanks to users in the community. Most communities have an adequate water supply most of the time, but in some communities there are periods of the year when the water supply is low. At such times, everyone must help by not wasting water. Scientists will probably solve the water shortage problem for coastal cities by putting into large-scale operation inexpensive ways of making seawater drinkable. But even then, inland communities will rely mostly on either surface water or groundwater for their sources of supply. And water treatment plants will continue their work of making water clear, correcting special problems, and killing bacteria so that water is available for distribution. In this film, you have seen certain procedures followed in a certain order. It is likely that your community does not use this exact method of water treatment. The reasons for this difference are interesting and important. Find out what the special problems are in your community's water supply. Learn how your community makes water safe and convenient for you to use.